All right, let's get right into it. Today, we're not just looking at a new piece of software. No, we're dissecting a strategic rebellion against the way things are usually done in AI infrastructure. We're going to break down the Axon architecture, which is really a blueprint for taking back control and achieving something called edge sovereignty. For years, the whole foundation of AI development has been these third-party APIs. It's convenient, sure, but it's a fundamentally flawed model. The people behind Axon have a name for it. They call it the Cloud API Trap. It's this dependency that just quietly eats up your resources, slows down your ability to innovate, and, maybe worst of all, puts your data at risk. So let's really quantify the cost of falling into this trap. First off, you're literally paying a tax on every single idea. Every inference, every task your AI runs is another line item on a bill from a big cloud provider. Second, you're fighting against physics with high operational latency. You're sending data all the way across the world and back again for every little thing. And then there's the big one, the critical failure point. You're handing your own proprietary data over to someone else. For any serious industrial-grade system, that's just a non-starter. It's an unacceptable risk. So how do you get out of this trap? Well, it isn't about just finding a cheaper cloud provider. That's missing the point entirely. It requires a complete paradigm shift in how we think about this stuff. The real solution is to fundamentally re-architect our systems and move that intelligence away from those centralized rented clouds and onto the edge, onto hardware that you actually own and you completely control. And this new paradigm has a name, the local first agentic pipeline. The two big principles here are data sovereignty and operational autonomy. What that really means is your AI agents are running locally on your machines. You own the whole process and you own all the data from beginning to end.
And look, this isn't some theoretical concept that requires a massive data center. Get this. This entire industrial-grade system is deployed and running right now on a standard Apple M1 Mac Mini. We're talking about a consumer device, something you can just go out and buy, with only 5.3 gigabytes of VRAM. This is huge. It proves that true AI sovereignty is actually within reach for pretty much anyone.
And that brings us to maybe the most crucial point. Once you own the hardware, what's the cost of one more inference? 1,000 more? One more task? It's zero. Nothing. You have your fixed upfront hardware cost, and that's it. After that, the marginal cost for intelligence is zero. This completely flips the entire economic model of AI development. It frees you from the tyranny of those pay-per-call APIs.
Okay, so how does this all actually work together? Well, a great way to think about this whole architecture is as an AI nervous system. It's this integrated local design where all the different parts work together seamlessly to sense, process, and then act.
Let's trace a job through the system. It all starts with a trigger, maybe from a mobile device, that gets sent securely over a private network using Tailscale. That request hits what's called the FastAPI Daemon, which is basically the central relay of our nervous system. The daemon then figures out what to do and routes the task to a local large language model. In this setup, it's a Gemma model running on a llama for local inference. After it thinks, the system takes action. It uses Notion as a kind of public logbook to keep track of its operations. And, most importantly, it taps into a local Obsidian vault. And this is key. That vault serves as its high-density, long-term cognitive memory.
Now, you're probably wondering, how can a relatively small model with limited VRAM possibly handle complex industrial-scale jobs? And that's where the real secret sauce comes in, the SAL Engine. This is the piece that makes running these powerful agents on consumer hardware not just possible, but practical.
So the core innovation here is something called fragment-based token fitting. Okay, imagine you have a really complex task that needs way more context than you can possibly fit into your model's limited memory. The SAL engine basically acts like an intelligent dispatcher. It looks at the whole task and dynamically breaks it down into a series of smaller, context-aware chunks, or fragments. Each one of those fragments is perfectly sized to fit within the model's VRAM. And as each piece is processed, the SAL engine is keeping track of everything, making sure the context and the results from the last step are passed on to the next. It's an incredibly clever and efficient way to get around hardware limits without losing the plot.
When you look at this approach, it really puts the Axon architecture on a completely different philosophical path from something like, say, the recently announced Apple Intelligence. And this isn't just about comparing features, it's about a fundamental difference in what the AI is for. Let's just break this divide down. Apple Intelligence is designed to be a seamless, system-level convenience. It helps you summarize an email or generate some text, all inside their closed ecosystem. Axon, though, is a totally different beast. It's a meta framework. It's not the final product, it's the toolkit for building highly specialized, autonomous worker nodes. Use AXON to create industrial-grade agents designed for a very specific job, giving you full control on your terms. One is a product, the other is a factory.
In all of this, every technical detail we've talked about, it all leads to one really powerful conclusion. The strategic imperative for any organization that's serious about using AI is to achieve sovereignty over its intelligence layer. The future isn't about renting someone else's AI, it's about owning your own.
And that right there is the essence of digital sovereignty. It's the power to not just use AI, but to build it and deploy it on your own terms. It means developing agents on your own hardware, running them with zero marginal cost, and guaranteeing absolute and complete data privacy. This is the end of the cloud API trap. It's the beginning of true operational independence.
So, as we wrap this up, I want to leave you with this question. Just for a moment, forget about the limitations. Forget the cost per call. Forget the data privacy worries. What kind of specialized, autonomous, and powerful systems will you build when your AI is truly completely yours?